For most of human history, our view of the cosmos never reached beyond the domain of our own sun. Yet, in just 8 short years, the unimaginable has occurred 3 times. From the silent depths of interstellar space, mysterious visitors have swept into our solar system, each more remarkable than the last. And now, against all odds, a new arrival has been spotted, racing inward at nearly 60 kilometers per second, larger and brighter than any before it, and discovered by chance in one of the most crowded starfields in the sky. No one expected such a find. This is the story of 3i Atlas, a comet that could reshape what we believe about life and matter beyond our planetary neighborhood. The outer edge of our solar system, past Neptune's orbit, dissolves into a vast, dark void. Few objects ever cross that frontier unless they were born here. In over 4 centuries of telescopic astronomy, only 3 confirmed objects have arrived from other stars. The first, Oumuamua in 2017, defied expectations, no tail, no coma, just a fleeting shard of light speeding along a trajectory no planet could explain. 2 years later, 2i Borisov appeared, unmistakably cometary, trailing a luminous halo and carrying chemical signatures from a nursery colder and older than any within our system. Now comes 3i Atlas, making 3 interstellar visitors against a backdrop of billions of native comets and asteroids orbiting the sun. The odds are staggering. The Milky Way hosts hundreds of billions of stars, each surrounded by clouds of dust, rock, and ice. But the distances between them are so immense that even debris flung away by violent stellar encounters drifts for millions of years before crossing another star's domain. Most of these fragments wander unseen through the void. Our solar system, dense with planets and asteroids, is still just a tiny target adrift in a vast emptiness. To illustrate, the Voyager spacecraft, launched in the late 1970s, only recently crossed into interstellar space after nearly half a century of travel. And even now, they are scarcely more than a single light day from Earth, while the nearest star is over 4 light years away. For 3i Atlas to find its way here, it had to thread an almost impossible cosmic needle. Astronomers estimate that perhaps 1 to 3 interstellar objects large enough to detect pass through the solar system each decade. Each one is a messenger, an ancient remnant carrying secrets from worlds we may never see again. On July 3rd, 2025, the ADLAS Survey Telescope in Rayo Hurtado, Chile, carried out its nightly sweep of the southern sky. 4 30-second exposures captured a faint point of light moving against the dense backdrop of the galactic plane. Specialized algorithms flagged its unusual motion, steady, consistent, unmistakable. Within half an hour, the candidate, provisionally labeled AO11PL3Z, was queued for human review. By sunrise, the ADLAS team had confirmed the object was real and submitted their findings to the Minor Planet Center in Cambridge, Massachusetts. Follow-up data poured in. The Zwicky Transient Facility found earlier traces, extending its observed path and allowing orbital calculations to tighten. The results were undeniable. The object's eccentricity was nearly 6. For comparison, a circle has an eccentricity of 0, while even the most extreme comets in our solar system rarely exceed 1.5. This meant 3i's Atlas was unbound. It would never return. It was a true interstellar traveler, crossing through once and then vanishing forever. What astonished astronomers even more was its speed. At 58 kilometers per second, 130,000 miles per hour, 3i Atlas travels almost twice as fast as Borisov and more than double Oumuamua's speed. At such velocity, it could cover the distance from Earth to the moon in just over an hour. No object born in our solar system could move this fast. Only a gravitational slingshot from a distant star could impart such momentum. Its orbit predicts a safe flyby of the sun. On October 30, 2025, 3i Atlas will reach perihelion at 1.4 AU, about 210 million kilometers from the Sun, farther than Earth's orbit. It poses no threat, only a fleeting chance to study a true outsider. Initial brightness estimates revealed something unprecedented, a nucleus up to 10 kilometers across, nearly 10 times larger than Borisov's core and far bigger than Oumuamua. That makes it the largest interstellar object ever observed. Surrounding it is a faint but real coma, a halo of gas and dust escaping as sunlight warms ancient ices. Unlike Oumuamua's barren shard or Borisov's hyperactive tail, Atlas displays a subdued but steady activity, somewhere between the two extremes. Its slow 29-hour rotation and even glow suggest a stable, hardened traveler, an ancient relic that has survived aeons in interstellar exile. The discovery triggered a worldwide effort. Robotic telescopes, amateur astronomers, and major observatories all joined in. Citizen scientists from around the world contributed images and data, blurring the line between professional and grassroots astronomy. Reports of outbursts, light curve variations, and tail morphology circulated rapidly through online forums, professional telegrams, and international collaborations. For a moment, the entire observing community, professional and amateur alike, was united by the thrill of tracking a wanderer from beyond the stars. Unlike its predecessors, 3i Atlas defies simple classification. Oumuamua gave us silence and mystery. Borisov gave us brightness and chemistry. Atlas offers a middle ground, a true comet, but modest in its outgassing, quiet and steady rather than dramatic. Its behavior forces astronomers to rethink what it means to be a comet from another star. Its origin remains unknown. Its speed and trajectory suggest it may have been cast adrift billions of years ago, perhaps as early as 11 billion years, long before Earth itself formed. That makes every measurement precious, each one a glimpse into a lost era of galactic history. Skeptics briefly speculated about artificial origins, as they did with Oumuamua, but the evidence here is clear: Atlas is natural. The true mystery lies not in whether it is artificial, but in what it can tell us about the environments where it formed. Time, however, is short. As September ends, the comet will slip behind the sun, hidden in its glare, invisible to even our most powerful instruments. It will reemerge in December, rising before dawn, offering one final chance for astronomers and skywatchers to study it as it recedes back into the void. For a brief moment, the cosmos has delivered us a relic from a distant past, a visitor from another sun, and perhaps the most substantial interstellar messenger we will see for generations. The arrival of 3i Atlas is more than just another astronomical discovery. It is a reminder that in a galaxy of billions of stars, each interstellar traveler carries pieces of a story far greater than our own. And with every new messenger, the universe whispers that most of its secrets are still untold.